You know how certain news items, like that recent ammonia gas leak in Ratlam, Madhya Pradesh, really make you stop and think? Especially if you're tracking current events for something like the UPSC exams.
Absolutely. It's concerning.
And what's striking is that these kinds of incidents, well, they aren't always isolated events, are they?
That's exactly right. As the articles we looked at from the Hindu really highlight, this unfortunate event in Ratlam really puts a spotlight back onto a persistent challenge for India,
Which is.
ensuring robust industrial safety protocols and, critically, having effective disaster preparedness strategies in place. It's a theme that keeps coming up.
Exactly. It's not just about the immediate crisis response. It's about understanding the bigger picture. And that's really what we want to do in this deep dive.
Mhm.
We want to equip you, particularly those of you prepping for the UPSC, with a solid grasp of what these industrial and chemical disasters actually involve.
And the legal side of things, too.
Yes, the existing legal safeguards here in India, and importantly, what concrete steps can actually be taken to, reduce our vulnerability.
This is the kind of stuff that's gold for mains answers, but also just essential awareness for prelims, too.
Okay, so to start unpacking this, maybe let's talk about the substance involved in Ratlam ammonia.
Right, ammonia. It's more than just, that sharp smell. Chemically speaking, it's NHR, a
Yes.
colorless gas. But yeah, with that very distinctive pungent odor.
And it's not just man-made, is it?
No, interestingly, it actually occurs naturally in various environments, even in the human body, in small amounts.
But industrially, it's a huge deal, produced on a massive scale.
Oh, absolutely. The main way it's made industrially is through the Haber-Bosch process. It's a really significant chemical reaction.
Okay.
You basically take nitrogen gas from the air, combine it with hydrogen gas, usually from natural gas, to produce ammonia.
Simple enough formula, but the process isn't simple, right?
Not at all. It needs very specific conditions. We're talking high temperatures, very high pressures, and you need a catalyst to make the reaction happen efficiently. So even just making it has inherent safety considerations.
Right, okay. So given those conditions for making it, what about ammonia itself? What are the key safety things to know?
Well, when it's concentrated, it's pretty corrosive.
Hmm.
That means it can cause serious burns if it comes into contact with skin or eyes.
Okay.
It also has the potential to explode if it's exposed to really high heat.
And how is it usually handled, like for transport?
Usually it's stored and transported as a compressed liquid. That makes it easier to handle in bulk, but obviously adds pressure consideration.
Makes sense.
And another key thing is it's highly soluble in water. When it dissolves, it forms ammonium hydroxide, which is also corrosive.
Okay, that's useful to know. I think I read somewhere it might have other uses coming up too, beyond the usual stuff.
Yes, exactly. There's a lot of interest in ammonia as a potential carbon-free energy carrier, like a fuel for the future.
Really?
Yeah.
How does it stack up?
Well, if you look at energy density, how much energy you can pack into a certain volume, ammonia actually holds significantly more energy than, say, lithium-ion batteries.
Wow.
Something like 9 times more per unit volume. And it even beats compressed hydrogen, maybe by about 3 times.
That's quite a difference.
It is. So that makes it a really compelling alternative fuel source as we try to move away from fossil fuels.
Fascinating. So, okay, that's the future potential. But right now, today, where's ammonia mostly used?
Oh, overwhelmingly. Its biggest use is in making fertilizers. Nitrogen-based fertilizers are absolutely fundamental for modern agriculture, for feeding the world, basically.
Can't argue with that. What else?
It's also widely used as a refrigerant, especially in big industrial cooling systems. Think food processing plants, ice rinks, that sort of thing.
Okay.
And then it's a key ingredient in making plastics, various synthetic fibers like nylon, and a whole range of other chemicals. It's a real workhorse chemical.
Okay, so clearly vital, but definitely carries risks we need to manage. Let's zoom out a bit then. How do we define these broader terms? Industrial disaster and chemical disaster.
Sure. So an industrial disaster is generally understood as a major accident that happens at an industrial site, a factory, a plant, whatever.
And the key is major impact.
Yes, resulting in extensive damage, significant injuries, or sadly, loss of life. The causes can be quite varied.
Like what?
Could be failures in the processes themselves, chemical, mechanical, civil, electrical systems failing, or it could be down to human factors. accidents, negligence, sometimes even incompetence, unfortunately.
And are there different categories within industrial disaster?
Yes, definitely. Chemical disasters like the ammonia leak are one major type, but you also have things like large explosions, mining accidents, incidents involving falling objects on big construction or industrial sites,
Right.
and in certain specialized industries, you could even have radiological incidents.
Okay. And do we have a sense of how often these things happen in India, particularly chemical accidents?
Yes. The National Disaster Management Authority, the NDMA, has actually tracked this. Their data suggests that over the last decade, India has seen around 130 significant chemical accidents.
130. And the human cost.
Tragically, those resulted in 259 deaths and over 560 major injuries. Those numbers really underline the scale of the problem we're talking about.
They really do. So how does a chemical disaster specifically get defined then as a subset?
Exactly. A chemical disaster is specifically about the accidental, unintentional release of one or more hazardous chemicals. Could be into the environment, could be within the workplace itself.
And the consequences are often severe.
Yes, potentially devastating. You can have immediate mass casualties, but also long-term damage to the environment, to ecosystems, and significant socioeconomic disruption, too.
What usually causes these chemical releases? Is it different from general industrial accidents?
There's overlap, of course, but common triggers for chemical disasters specifically include accidents during the industrial process itself, maybe improper handling or storage of dangerous substances.
Yeah.
And critically, the failure of safety systems, the very systems designed to prevent these releases in the first place.
You know, hearing these definitions is one thing, but connecting them to actual events makes it much clearer. The source material mentions some key examples in India.
Absolutely. Looking at specific incidents really helps. For instance, just earlier this year, 2024, there was that ammonia leak in Chennai.
Yes, I remember that. What was the cause there?
It seems a pipeline was damaged during Cyclone Mashong. So it shows how natural disasters can sometimes trigger these industrial or chemical accidents.
It's a cascading effect.
Precisely.
Mm-hmm.
Then you have the Vizag gas leak back in 2020. That was styrene gas leaking from the LG Polymers plant in Visakhapatnam. Caused serious health problems and, sadly, fatalities, too.
A terrible incident.
And, of course, you simply can't talk about chemical disasters in India without mentioning the Bhopal Gas Tragedy in 1984.
The scale of that was just unimaginable.
Exactly. The leak of methyl isocyanate, MIC, from the Union Carbide plant. It remains probably the world's worst industrial disaster in terms of immediate death toll, a truly stark reminder of the potential consequences.
It really is. And it underscores just how vital preventative measures and a strong legal framework are. So, speaking of that, what legal safeguards do we have in India to try and prevent these things, or at least deal with the aftermath?
India has actually put together a fairly comprehensive legal framework over the decades, often in response to these very tragedies.
Like Bhopal.
Yes, a key piece of legislation came directly from that. The Bhopal Gas Leak Processing of Claims Act, passed in 1985. Its specific purpose was to set up a system for processing compensation claims for the victims.
Makes sense. A direct response. What about broader environmental laws that would cover industrial pollution or hazards?
For that, the cornerstone is really the Environment Protection Act, the EPA, from 1986. It's kind of an umbrella law. It provides the overall framework for protecting and improving the environment. And that definitely includes powers to regulate hazardous substances used in industry.
I also saw a mention of something called the National Environment Appellate Authority, NEAA. What did that do?
The NEAA. It was set up under an act in 1997. Its job was essentially to hear appeals against environmental clearances given to projects.
So, like a check on project approvals.
Exactly. The idea was to bring more transparency and accountability to environmental decision-making, which indirectly helps prevent potential disasters by scrutinizing projects that might pose risks.
And has it been replaced?
Yes, its functions were largely taken over by the National Green Tribunal, the NGT, which has a broader mandate now. But the NEAA was an important step.
Okay. What about helping people affected by accidents, getting them quick financial help?
Right, that's absolutely crucial. That's where the Public Liability Insurance Act, or PLIA, from 1991 comes in.
Insurance, okay.
It mandates that industries handling hazardous substances must have insurance cover. The specific aim is to provide immediate, interim relief and compensation to victims if an accident happens involving those materials, without waiting for long legal battles sometimes.
That seems vital for the people living near these facilities. I also remember reading about specific rules for managing hazardous waste itself.
Yes, the Hazardous Waste Management, Handling, and Transboundary Movement rules. They first came out in 1989 and have been updated since.
And what do they require industries to do?
They place several obligations on industries that generate hazardous waste. Things like identifying potential accident-prone zones within their own sites, putting preventive measures in place, and importantly, reporting any hazardous situations or potential problems to the authorities.
So, a lot of focus on prevention and accountability. Are there other major legal or regulatory pieces we should know about?
Definitely. The NDMA, which we mentioned earlier, has also issued specific national guidelines on chemical disasters.
Yeah.
These are quite detailed and provide a kind of roadmap for everyone involved, government agencies, industries, communities, on risk reduction, mitigation, and preparedness, specifically for chemical hazards.
Okay.
Then there's the Factories Act of 1948. It's an older law, but still very relevant. It contains a lot of safety provisions specifically aimed at protecting workers who handle hazardous substances in manufacturing settings.
Good. And anything else?
One more worth mentioning is the Insecticides Act of 1968. It regulates the whole life cycle of insecticides, import, manufacture, sale, used primarily to minimize risks to human and animal health, but it's relevant in the broader chemical safety context too.
Okay, this does sound like a fairly developed domestic framework, but sometimes these incidents or the materials involved cross borders. What about international cooperation or standards? Is India part of global efforts?
Yes, that's a really important dimension. Chemical clouds don't respect borders, and hazardous waste sometimes gets moved internationally.
Yeah.
So international cooperation is vital.
So what are the key frameworks?
Well, a major overarching one is the Sendai Framework for Disaster Risk Reduction, which runs from 2015 to 2030. It's a global agreement setting targets and priorities for reducing disaster risk worldwide, including technological disasters.
Okay, that's broad. Are there conventions focused specifically on industrial accidents crossing borders?
Yes, there is. The UN Convention on the Transboundary Effects of Industrial Accidents from 1992. It sets up a legal framework for countries to cooperate on prevention, preparedness, and response if an industrial accident in one country could affect others.
That seems necessary. What about the movement of hazardous materials like waste?
For that, the key one is the Basel Convention. It deals with the control of transboundary movements of hazardous wastes and their disposal, adopted back in 1989.
And its goal?
It aims to regulate the international trade or movement of hazardous waste, making sure it's managed and disposed of in an environmentally sound way, and trying to prevent illegal dumping, which can lead to its own disasters.
Right. I think I've also heard about rules for trading hazardous chemicals, not just waste, making sure importing countries know the risks.
Ah, you're probably thinking of the Rotterdam Convention. That came into force in 2004.
Yes, that's familiar.
It promotes shared responsibility between exporting and importing countries when trading certain listed hazardous chemicals and pesticides. It uses what's called a prior informed consent, or PIC, procedure.
So the importer has to agree.
Essentially, yes. It ensures they get the necessary safety information to make an informed decision before agreeing to import these substances.
Okay. Are there any, broader international policies for chemical safety overall, not just accidents or trade?
Yes, there's the Strategic Approach to International Chemicals Management, or SAICM, adopted in 2006. It's a global policy framework aiming to achieve the sound management of chemicals throughout their entire life cycle, from cradle to grave, basically.
Okay.
And related to that, UNEP, the UN Environment Program, developed what they call a flexible framework for chemical accident prevention and preparedness, also from 2006.
Flexible framework.
Yeah, the idea is to offer a flexible approach that countries, especially developing ones, can adapt to build up their own national programs for preventing and preparing for chemical accidents.
That sounds practical. Any other major international players in this space?
Well, the OECD, the Organization for Economic Cooperation and Development, has a very significant and long-running program on chemical safety and biosafety, started back in the mid-80s.
And what does that cover?
It works on developing standards and guidance for the safe use and management of all sorts of things: industrial chemicals, nanomaterials, pesticides, biocides, even products of biotechnology. They contribute a lot to international best practices.
Okay, wow. That gives us a really good sense of the legal and international context. Now let's bring it back home to India. What concrete steps can we actually take here to reduce our vulnerability further? This feels really key, especially for UPSC aspirants thinking about policy solutions.
Absolutely. This is where we translate understanding into action. There are several key areas. One really crucial step is better risk mapping and hazard zonation.
Okay, what does that involve?
It means using modern tools like GIS, Geographic Information Systems, to create detailed hazard maps of all the major accident hazard, or MAH units across the country.
So we know exactly where the biggest risks are located.
Precisely. Identifying the vulnerable zones around them, especially where they overlap with populated areas. And then, crucially, mandating effective safety buffer zones around these facilities. No new construction too close.
That makes sense, like zoning laws, but specifically for industrial hazards.
Exactly. And this kind of planning directly links to the Sustainable Development Goals, by the way. SDU 11 on sustainable cities and communities, and SDG 3 on good health and well-being. It's about safer development.
Right. A very tangible step. What about strengthening our institutions and policies themselves?
Continuous improvement is key.
Right.
We need to keep reviewing and strengthening the NDMA's guidelines on chemical disasters. Make sure they're periodically updated, aligned with the latest global standards and practices, and perhaps establish more specialized institutions, both nationally and at the state level. Dedicated centers for advanced training for emergency responders, better planning.
And integrating these plans.
Yes, ensuring chemical disaster response is fully baked into the district and state disaster management plans, not just an add-on. This means clear, standard operating procedures, or SOPs, that everyone knows.
And practicing them.
Absolutely essential. Regular, realistic mock drills are non-negotiable to actually test if the plans work and if people know what to do.
So it's not enough to have the laws and plans. We need to make sure they're followed. Enforcement.
Effective enforcement is probably one of the most critical and sometimes challenging aspects. We have good laws on the books. The Factories Act, the EP Act, those MSIHC rules from '89, the Public Liability Insurance Act.
Right.
These need to be enforced rigorously. That means inspections, audits, and crucially meaningful penalties for violations that actually act as a deterrent.
And what about the emergency response infrastructure itself?
We need to ensure we have well-equipped emergency response centers, or ERCs,
Yeah.
and they must be properly integrated
Integrated with whom?
with all the key first responders, police, fire services, the state and national disaster response forces, SDRF, NDRF, and the health services, hospitals. They all need to work together seamlessly.
Oh.
And another key enforcement aspect is mandating and actively supervising off-site emergency plans. These are plans for protecting the community outside the factory gates, managed by the district authorities. That needs close oversight.
Beyond boots-on-the-ground enforcement, can technology help more?
Oh, absolutely. Technological surveillance is a huge area with potential. We're talking about using real-time monitoring systems.
Like sensors.
Exactly. Sensors to detect leaks or dangerous conditions early. Implementing robust early warning systems that can quickly alert both the plant workers and the nearby communities.
Okay.
Using better surveillance tech for tracking the storage, handling, and transport of hazardous chemicals. And also really promoting the use of sophisticated risk assessment methods within industry itself.
Like HAZOP, I've seen that term.
Yes, things like hazard and operability studies, HAZOP, and hazard analysis, HAZAN. These are systematic ways for industries to proactively identify potential problems in their processes before they lead to accidents. We should encourage, maybe even mandate, their wider adoption.
And sometimes a little encouragement helps industries invest in safety, right? Incentives.
That's a very valid point. Incentive support can be really effective, offering things like targeted tax breaks or subsidies.
For doing what?
For industries that invest significantly in upgrading their safety infrastructure or adopting new, proven safety technologies, it can help accelerate safety improvements, especially for smaller companies maybe.
Makes sense. I also saw a reference to a more recent piece of legislation, the Occupational Safety, Health, and Working Conditions Code, 2020. How does that fit in?
Ah, yes, the OSH code. It's quite significant because it consolidates a lot of older labor laws related to workplace safety and health into one framework.
So it's about worker safety primarily.
Yes, but that's directly linked to preventing broader industrial disasters. It clearly lays out the safety responsibilities for both employers and employees across many sectors.
Okay.
It also mandates industry-specific safety standards, focuses on worker welfare, things like working hours, health checks, leave policies. It provides protection for contract workers, too, and promotes gender inclusivity.
So a healthier, safer workforce is less likely to have accidents.
That's the core idea. A comprehensive focus on worker safety and well-being is a fundamental part of preventing industrial accidents and disasters. Safer work environments, safer practices.
This has been incredibly thorough. It really paints a picture of a complex challenge, especially for a country like India that's industrializing so rapidly. So if we were to boil it down, what's the main takeaway here?
I think the core message, underscored by incidents like the Ratlam leak mentioned in the Hindu, is the continuing urgent need for a really robust, multi-layered approach to chemical disaster preparedness in India.
It's not just one thing.
No. As our industrial footprint grows, it's absolutely essential that we prioritize strong institutional vigilance, meaning regulators doing their job properly. We need proactive community awareness programs so people living near these sites understand the risks and know what to do.
And technology.
And definitely leveraging technology-driven safety measures across industries. But perhaps overarching all of that is fostering a deeply ingrained culture of zero tolerance for safety lapses.
Zero tolerance.
Yes. That's ultimately what's needed to protect lives, safeguard our environment, and ensure that our development path is truly sustainable.
Absolutely. Well said. So, for all of you dedicated UPSC aspirants listening in, we really hope this deep dive has given you some valuable background and context on what is clearly a very important issue. Understanding the nature of these potential disasters, the legal and international frameworks around them, and, crucially, the measures India can and should take for better preparedness, it's all vital for tracking current events and for building that comprehensive understanding of governance and safety needed for both mains and prelims.
Definitely.
If you found this discussion helpful, please do give us a like and subscribe for more deep dives into key topics.
And we genuinely want to hear from you.
Yes, please leave a comment below. Let us know your thoughts, any further questions you have, or perhaps other topics you'd like us to tackle in future sessions.
Your feedback helps shape what we cover.
And just to be clear, the information we discussed today was drawn primarily from reporting and analysis in the Hindu.
Right.
Finally, we'll leave you with a thought to mull over. As India powers ahead with industrial growth, how do we strike that critical, maybe difficult balance? The balance between driving economic progress and absolutely ensuring the safety and well-being of our citizens and the environment they live in.
It's the central question, isn't it? Finding that sustainable path forward.
Indeed. Something to definitely keep thinking about. Thanks for tuning in.